So we'll give you an introduction to the Dart jump shots, and for those of you who are not familiar with the terminology, jump shot, that is the new model of the Dart. And some of you may have experience with the original Dart SVP or the Dart OS, and we'll give you an introduction to what is the new thing with the jump shots. So very shortly we'll talk about who we are and who IronSons are. Then we'll talk about the actual topic, namely what is the Dart jump shots, and especially the jump shot improvement over the old Dart system. We'll talk about how much gas you save with the new model, the sensitivity change. We'll talk a little bit about the theory of operation, and shortly how to get one, or rather what is the compatibility on the Dart jump shots. And lastly, we'll have a questions and answers session. And during the webinar, you're welcome to write any questions you might have in the chat box, and we'll try to go through the questions at the end of the webinar. So MSCi is a small Danish company. We've been around for 23 years by now, and we are the distributor in the entire Europe of the IronSens products, which is mostly the darts and also the ASAP, if you may know that. IronSens is the manufacturer of the darts, and they recently introduced the jump shot model. This is an ion source for mass spectrometers in general. They're located in Boston, in the US, or rather Saugus, which is just outside of Boston, while we are located in Copenhagen. The Dart is direct analysis in real time, and this is the entire point of the Dart. It is direct analysis, which means that it happens in open air, just in front of your mass spectrometer, not in an enclosed interface. That makes the sample introduction easy, quick and easy, and it's in real time, so you don't have any chromatography to wait for, which is sometimes a plus, sometimes a minus, but it makes the possibility of doing rapid non-contact surface sampling. The new model is called the jump shot, or in many cases just the JS. It introduces the gas pulsing, and that was the main change from the old model, so-called SVP. The jump shot is a name that refers to the pulse technology, and the main change is that you don't have a constant gas stream while doing the analysis. You did just turn on the gas before, and then you waited until your analysis was over and you could switch back to the standby gas. Today, you have the possibility of turning on the gas only while sampling and then having the gas off while you are not doing any active sampling. Doing this concentrates the peak to a sharper peak. The peak is only there when you have the gas flow on. When it's off, you don't have any ionization, you don't have any desorption of your sample. That also means that the rail can move faster between samples, and it therefore also reduces the analysis time. So both throughput and sensitivity is improved this way. So what you do is that you turn off the gas between sample positions. That means the rail can move faster, and it reduces the analysis time, and How much is a little bit dependent on the type of analysis you do, but you can say that up to a factor 3 in the best case analysis time, 3 times shorter analysis time. But it also means that the gas is turned off between the samples, and that means you can save quite a lot of helium. For the samples point of view, it means that the desorption and ionization happens as soon as you turn on the gas. It happens immediately. But while you were on the old model, the SVP, you had the gas on all the time. And as soon as the rail moved closer to the sample, the desorption and ionization began to happen gradually as you got nearer to the sample. But that means that you get a more efficient desorption and ionization, and that gives you a better signal to noise ratio, in the end leading to better sensitivity. A little animation here shows that first you move the sample to the position, then you turn on the gas, do the ionization, and when the gas pulse has passed, you turn off the gas, and now you can get ready for the next sample. So you create the ions just in the sample region, but they are created only when you have the gas on. Nothing happens when the gas is off. It's just positioned just in front of the dart source. So how much gas do you actually save? And this is a quite theoretical question, of course, because it depends greatly on your parameters. So if we take 2 typical examples, we have 384 positions. That is a standard high throughput card, which could be sampled directly from a deep well plate with 384 positions. If you sample 1 second for each sample, that gives you 384 seconds of sampling time, active sampling time. That is 6.4 minutes. A typical high throughput analysis would take a little less than half an hour. And that means that 1/5 of the time, roughly speaking, you'll have the gas on. The rest of the time, the system uses for moving between sample positions. But if you compare it with a traditional analysis, with the SVP model, with constant gas flow, this would typically take around 1 hour to sample a sample card like this. And for this, you get a gas save ratio of around 89%. So around 90% of your helium is saved. And that, of course, sounds great in many cases because helium is expensive. But how much is actually saved will, of course, depend on what kind of sample do you have. Do you need longer pulsing time? That will give you a less gas save ratio. If you can do with just half a second, you can get an even greater reduction in gas usage. Another example would be a typical quick strip card. It has 12 positions. If you can sample these for just half a second, that gives you a total of 6 seconds sampling time. That will normally take around 60 seconds, 1 minute, and that gives you also 90% reduction in gas usage. This sounds very promising, of course, but again, it will only work if your sample can be analyzed in just half a second. If you need more sampling time, you will get a less gas save ratio. So a little bit talk about the analysis gas and standby gas. The analysis gas is often helium. It could also be nitrogen. That depends a lot on the sensitivity requirements of your analysis, but it also depends on the availability of gas. I mean, if you want to use the extra cost for using helium for the greater sensitivity you usually get from helium. For standby gas, you would typically choose a cheaper gas type that would normally be nitrogen. The purity requirements are not as high for the standby gas. There you could often use generator nitrogen, so it could be from a gas generator. That would not work for analysis gas. They'll need properly pure bottled gas. So the standby gas could be more or less free, while the analysis gas is typically relatively costly. So the procedure is that you turn on the standby gas all the time when the dart is on, and you have it on until just before you're ready to start the analysis. Then you turn on the analysis gas for a short time before starting the sampling, and that is to stabilize the gas flows, but it's also to purge the source for the standby gas. You want to have only the pure analysis gas ready inside the dart source before starting. From there on, the analysis gas will be on only during the sampling, so it will turn off the analysis gas, move to the first sample position, then turn it on, do the analysis, turn it off, and then move to the next one, the next sample position. And when you're done with the entire analysis, you will switch back to the standby gas to save the costly analysis gas, and you use the cheaper standby gas. So in the end, you have the analysis gas on only during the pulses and a short stabilization before that. So the darts compared to the old dart, the jump shot with the SVP compared, is still a web browser interface. All methods and software is run from the controller. That will sound familiar to you that are familiar with the SVP systems, and that's because it's just the same thing. It's a modern facelifted software, but it's essentially the same. So the theory behind actually means that it's the same thing. You will also see when you look at the controller and the source that there's a very great similarity. It's much of the same hardware with a new capability. So the thing that I'm most often asked is actually, what is the sensitivity increase, and why is there a sensitivity increase? And the whole point is that you move to the sample before starting the analysis, then you do a short pulse with hot gas for a short time, and you get the sample desorbed very quickly. When you move slowly against the sample position, you will see a gradual increase in signal. Then you'll see the signal being there for some time, and then you'll see it disappear as you move on to the next sample. And why is this? This is partially because you do the entire gas shot while being in front of the sample, but also because when you have this gas inside the source, it's better heated, so it's actually a bit hotter than when doing the continuous gas stream. And you can see an example on this page that on the top, it should be the same time scale, and you'll see that you get much sharper peaks, and they are much higher, they have a much better sensitivity, signal to noise ratio, and that gives you a better sensitivity. It's a little bit difficult to say exactly how much sensitivity you gain. In best case, I would say around a factor of 10 for quick strip cards. But it will depend on your sample matrix. It will depend on how you do the analysis and what your experiment module is. So you can win quite a lot, but it depends on your actual analysis. But the theory is that you can do much shorter desorption to get the sample properly out of the matrix. So you can see here that you have one quick strip card run in the time frame here, while you have 36 samples run with the pulse gas. So you may have seen this before. This is how it actually happens, and this is the same between the continuous gas operation and the pulse gas. So you excite your ions with the high voltage needle, then you heat the gas. So what you get out of the source is hot gas that has excited molecules. And those excited molecules will give off their energy to either the sample directly, which means that the sample could give M plus or M minus ions, depending on what kind of ionization they prefer. But it could also ionize water, giving H3O plus ions, which in the end could give off protons, so you get protonated ions, M+1 ions. If you're working in negative mode, you can get similar ionization just with negative reactions, and you can actually get quite a lot of different and sometimes even weird or surprising, I'd rather say, chemistry happening. So for many molecules, you can have different kinds of ionization. It will be the same for from each run to run, but it will be different from molecule to molecule what it prefers of ionization. Before I talk about this part here, I'd like to mention that for those of you thinking that the jump shot may sound like a nice thing, but it may still be important to be able to use the old kind of continuous gas stream. This is something you can still do. You simply select whether to use pulse gas or continuous gas. It's both included in the package. So how do you actually get a dart jump shot? But you have perhaps already a dart and want the jump shot possibility. And for that, we have upgrades available both for the Dart OS, the Dart SVP, and the Dart HT, the high throughput. So one change is that the automation rails are new, so some of the hardware will need to be changed for the SVP and the HT systems. For the Dart OS, it's primarily a software upgrade. The Dart 100 cannot be upgraded. We have some trade-in possibilities, but it's too old. It's not supported anymore. And if you don't have a Dart already, then let us know what kind of solution you want, and we will in almost any case be able to tell you that the jump shot is supported by your mass spectrometer. So lastly, some pictures from before the Corona time. So So when it was still possible to get a haircut, and this is me and Mads, your contact persons, if you want to have any kind of information on the darts, on the jump shots, on applications, whatever you might want to know regarding the dart, we will be your contact persons. And lastly, if anyone has any kind of questions, we'll be happy to answer them.